All right, next lecture, Newton's third law. So we've talked about Newton's first two laws, and now we get to his third law, which is basically that every force has an equal and opposite reaction. Forces come in pairs. And this is true with every single force, no matter what. If object A exerts a force on object B will always exert the same force, same magnitude, same number of newtons in the opposite direction back on object A. This is true with everything, such as like tension, friction, normal force, like when you have a gravitational force pulling something down. Newton's law states that there's always going to be a opposite force with the same exact magnitude in the opposite direction, and we call this the normal force in the case of which the original force is gravity. And in all these cases, the main idea is that forces come in pairs and that there's always an opposite force for every force that we take a look at. So this sets up problem number 8, and problem 8 says that a ball of mass m is dropped from rest, goes down from a height h. This isn't really relevant in the problem. And then it collides elastically with the floor, meaning that it bounces off with the same exact momentum. But it asks, what is the average force applied by the floor on the ball? So this will move down, and it's going to be in contact with the floor. It just bounced down. It's just about to bounce up. And while it's in contact, it's asking what force is the floor exerting on the ball, B. And the answer comes straight from Newton's third law. It's the same as the force that the ball is exerting on the floor. And that force is just gravity, because gravity is always pulling the ball down. And while it's touching the floor, it's going down, force pulling it down at a magnitude of m times g mg. So therefore, it's the same exact force that the floor is putting on the ball, going in the upwards direction of mg, which is answer choice B.